Hey guys, how are you doing? So welcome back to our discussion on vector analysis, and now we begin today with dot product. तो जो हम vector algebra के बारे में बात कर रहे थे, let me again remind you guys, vectors have two things, and which is magnitude and their direction. But it is not it is necessary condition but not sufficient, है ना? ये ध्यान रखना. तो ये इसके पास क्या होता है, एक magnitude होता है, and apart from magnitude the vector have directions. Okay, but this is not sufficient. Okay, what else? I have already talked to you about vector algebra. They have their own algebra, and vector has to follow their own algebra, which is called vector algebra. And in this particular pursuit, now we are going to talk about dot product, है ना? अच्छा, dot product की सबसे पहले खास बात ये है कि it is just defined in a plane only. So you don't need to consider three-dimensional plane. What is the good news about this? Suppose you have this plane like okay, आपके पास मान लो ये कोई plane है. Okay, this is a plane where I am trying to take two vectors and their dot product. Okay, dot product of two vectors. तो ध्यान से समझने की कोशिश करना. Okay, एक मिनट है ना, देखो नीचे क्यों नहीं आ रहा है. Okay, no, okay. अगर मेरे पास यहाँ पर दो प्रोडक्ट हैं और कार्टेशियन कोऑर्डिनेट सिस्टम में, रेक्टेंगुलर कार्टेशियन कोऑर्डिनेट सिस्टम में ध्यान से समझने की कोशिश करना. We have right-handed system. What is right-handed system? We could have left-handed system also. Again, this course is for theoretical physics. तो हमारी ये अंडरस्टैंडिंग होनी चाहिए कि how theory is developed, है ना? We should understand how we develop theory. देखो, right-handed system का मतलब ये है कि अगर मैं अपना राइट हैंड वेक्टर ए पे रखूं या किसी कोऑर्डिनेट एक्सिस एक्स एंड वाई पे रख दूं, एक्स एंड वाई, है ना, तो जो मेरा अंगूठा होगा दैट इज गोइंग टू बी इन द जी डायरेक्शन और जेड डायरेक्शन. सो दिस इज कॉल्ड राइट हैंडेड सिस्टम. लेफ्ट हैंडेड सिस्टम होता तो मैं क्या करता, ए पे हाथ को रखता, बी की ओर करता, और जहां अंगूठा जाता वो मेरा डायरेक्शन क्या होता, जेड एक्सिस होता. बट हम राइट हैंडेड सिस्टम की अगर बात कर रहे हैं तो इसका मतलब इन दिस पर्टिकुलर राइट हैंडेड सिस्टम यू हैव दिस प्लेन. दिस इज वेक्टर ए, है ना. हालांकि मेरे को अभी तो सिर्फ प्लेन की जरूरत है. So vector A, this is vector B, okay, and this vector is by definition, if you dot product them, so you are going to have this A dot B is by definition length of vector A, length of vector B, and angle cosine cos theta, right? This is the definition of, and ये three dot का मतलब है definition. तो ये जो तीन मैंने आपको लाइन बना दी, this is not congruency, this is by definition, shorthand notation for by definition, okay. Or simply what you can write, you could have written A dot B equal to, if I am not using arrow, it simply means I am using their magnitude. This is the length part, okay. So A dot B equal to AB cos theta. That is the basic idea, okay. Now interestingly, what you can easily prove, what you can easily see here, A dot B is just same as B dot A. It is commutative, okay. So dot product is commutative, most importantly, okay. So dot product is commutative. So order is irrelevant, order is not material, it is immaterial. So this is called a commutative property, most important, okay. In case of cross product, we are going to talk soon. Commutative property doesn't hold. So it is the good thing about ये क्या है, commutativity को क्या करता है, okay, hold करता है. How about distributivity? Distributive, it is distributive also, okay. And you can say distributive over addition. कैसे? अगर आपके पास A vector है, then if you want to use B plus C dot B plus C, because B plus C is again due to closure property, it is going to give you a vector itself. So A dot this, what it is going to give me, this is going to give me equal to A dot B plus A dot C. Again interesting property, okay. This is distributive property. अच्छा, अगर मैं एक स्केलर का मल्टीप्लाई करूं A dot B में, तो it is not going to make any difference, wherever it goes, it can go anywhere, okay. So I have a scalar lambda. If it is going to get multiplied with two vectors, dot product of two vectors, okay, which is a scalar quantity obviously. So I can write it like this, lambda A dot product B. It is same as A dot lambda B. It is same as if you want to write down A dot B first and then you want to multiply right from right side, lambda. What is lambda? Lambda is again scalar quantity. I hope this is all clear to all of you, right? So what is lambda? Lambda is a scalar quantity. You might write somewhere lambda is a scalar quantity. Lambda is a scalar. Okay. All right. In our now I am going to talk about rectangular coordinate system. ओके सो cos थीटा, अगर आपको यहाँ से कभी भी किसी भी एंगल के बीच में एंगल निकालना हो दो वेक्टर के बीच में, तो cos थीटा इज गोइंग टू बी, यू कैन फाइंड आउट दिस नंबर a डॉट b which is a scalar quantity and then divided by simply ab. Okay, this is how you identify cos theta. You know cos 90, if theta equal to 90 degree, if two vectors are mutually perpendicular, then their dot product is going to be 0, right? So suppose this is your vector a and you have another vector b. तो a dot b के बारे में जब भी मैं बात करूंगा, and if these vectors are perpendicular vectors, suppose this is vector a, this is vector b, the necessary condition of perpendicular, two vectors are perpendicular, being perpendicular is a dot b, the product dot product is 0. Okay, so cos 90 is equal to 0, a dot b is obviously it is going to be 0. That's the most important aspect in this whole game, right? Now in our coordinate system, suppose again, not necessarily we are going to use this coordinate system, but yes, फिलहाल अगर हम इसकी बात करें, rectangular right handed जो अपना क्या है coordinate axis है, rectangular coordinate system राइट हैंडेड सिस्टम है. राइट हैंडेड सिस्टम का सीधा सीधा ये मतलब है, अगर ये मेरा एक्स एक्सिस है, ये वाई एक्सिस है, and if I rotate it like this from x to y, g axis is going to be in the direction of the thumb itself. Okay, suppose if you were to define a plane here, okay, like this, okay, take this is a vector. So what you are going to do, you are going to take, okay, what you are going to do, you are, okay, no, this one, I am interested about this line, okay, not this line. So what you are going to do, you are going to bring this line here. Now this is a parallel line, but I need this parallel line somewhere here. So this is xy plane. I hope you can understand, है ना? तो आपको ये दिख गया होगा. This is xy plane, okay, with this diagram. This is xy plane. I think we can do it, है ना? अगर मैं इस कोऑर्डिनेट सिस्टम को और ऊपर खींचूं ऐसे, like perpendicular to g axis or z axis, like this, okay, then like this, okay, and now if I were to bring this line here, bring this line here, है ना? तो अब आपकी समझ में आ जाएगा मैं कर क्या रहा हूँ, what I'm doing. I hope you can make sense what I'm doing, okay? इसको देखो ऐसा, है ना? अगर मैं यहाँ पर कोई दो वेक्टर्स लिखूं जिनके तीनों कंपोनेंट मेरे पास है, suppose I have all three components with me, okay, this is how it look like. Okay, I have two vectors and they are in 3D plane. You get to understand. Okay, this is one, okay, this is one vector. Let's say I have another vector, okay, यहाँ पर कहीं 3D में, I have another vector, two vectors. Okay, so what is the, this is vector A. What are the coordinates? Let's say coordinates are x1, y1, z1. So it's better if I say ax, ay, az. This is bx, by, bz. Again in 3D. Okay, this is angle theta. तो कहीं तो ये क्या होंगे, ये वेक्टर्स होंगे. सो हाउ डॉट प्रोडक्ट इज डिफाइंड, एंड नाउ यू कैन डिफाइन द डॉट प्रोडक्ट ऑफ these two vectors, okay, and they are at angle theta, right? How do you define a dot b? Now a dot b is going to be again ax I cap. All right, okay, let me take this whole diagram little left. Okay, now a डॉट बी जो वेक्टर है ये होगा क्या, अगर आप देखेंगे डॉट प्रोडक्ट आपको लेना है ए और बी का, लेकिन उससे पहले बिफोर दैट व्हाट यू नीड टू अंडरस्टैंड, these unit vectors are mutually perpendicular, they are orthogonal set, right? I you know, okay, and the or these are three vectors I j k. Okay, these are the unit vectors, and try to understand in the direction of I j k. You have, you know, the condition, the basic condition. You have this condition: I dot j equal to 0, j dot k equal to 0, because they are perpendicular. K dot I equal to 0. Obviously, they are you know, commutative also. So it is not going to make any difference if I take j dot I, right? I dot I equal to 1, j dot j equal to 1, k dot k equal to 1. Why? Because cos 0 equal to 0, right? So we can write for any two vectors, like, you know, I don't know how to do that, but if I have, let's say, ei ej, now we are going to go get into, you know, some kind of shorthand notation, some kind of, you know, mathematical you know, beauty, elegance, right? So if I have ai aj, so I can say ai aj equal to uh, or okay, equal to 1 if I equal to j, and it is 0 if I does not equal to j, you know, this kind of condition where these are the unit vectors. Now I am defining, you know, these are the unit vectors, okay, for any combination for that matter, unit vectors. तो orthonormality जो condition है basically, you know, this is the condition. So I dot I equal to 1, so E1 dot E2 equal to 0, E1 dot E1 equal to 1 if E1 E2 are the unit vectors. But anyways, I am going to talk about it little later. AX I cap, AY J cap plus AZ J cap, K cap, sorry. Similarly, BX I cap, BY J cap plus BJ BZ K cap. Okay. Now, when you apply I dot I equals to 1, I dot j equal to 1, you simply get A dot B equal to, you have this component along x-axis of the vector A, it is going to get along with B vector, Vx x component, similarly AY, BY, and similarly AZ, BZ. This is the A dot B condition. Simple as this is. No need to, okay. I can also identify a vector dot a vector is going to be by definition a square cos 0. It is simply equal to a square. Again, a dot a vector is going to give you a square, and with component you have ax square, ay square plus az square. If you remember, other last time we have done something else, I don't remember exactly, but हमने ऐसे निकाला था, ठीक है. तो a vector is going to be ax square, ay square plus az square. This is the, what is this? This is basically what? Magnitude. And similarly, this b vector is by definition, it is going to be bx square, vy square, vz square. Okay, so I need to pause for a second. All right, so give me okay. So what we have been talking, you know, so far we were talking about the dot product, how does this work? And similarly, what we can find out, the magnitude of the vector A and B both, right? Okay, so what is the condition for the perpendicular vector? It is A dot B equal to 0 and A and B are not both null vectors, then it is a condition for perpendicular. Okay, now we are going to solve some questions, right? Prove that the projection of vector A and B equal to A dot B, where B is a unit vector in the direction of B. तो आपको क्या बताना है? प्रूव दैट द प्रोजेक्शन ऑफ ए ऑन बी इज इक्वल टू ए डॉट बी वेयर बी इज द यूनिट वेक्टर. ओके, देखो मैं आपको समझा देता हूं. जो ये बी वेक्टर है, तो अगर हम बी वेक्टर को लिखेंगे तो बी वेक्टर कैन बी रिटन एज बी इंटू बी कैप. ओके, व्हाट इज बी कैप? बी कैप इज गोइंग टू बी इक्वल टू बी ओवर बी. ऑलराइट, अगर आपको इसका प्रोजेक्शन चाहिए, इफ यू नीड अ प्रोजेक्शन फॉर vector A along vector B, then what it is going to be? Actually, it is going to give you simply what you have to do. You have to take it like, आपको क्या करना है बेसिकली, A वेक्टर का जो प्रोजेक्शन है, इसका मतलब अगर मैं A से यहां से B के ऊपर जो इसके प्लेन पड़ेगा, वो प्लेन क्या पड़ेगा? तो इट इज एक्चुअली A cos थीटा, है ना, एंड दिस इज A sin थीटा. तो अगर आप देखेंगे तो दिस GB, दिस G into B, GB vector, it is basically A cos theta, and when you talk about its magnitude, है ना, तो जो इसका मैग्नीट्यूड है GB का, वो क्या हो जाएगा? A cos theta हो जाएगा बेसिकली. एंड मैं आपको बता देता हूं इंटरेस्टिंगली, इट इज सेम एज EF, है ना, इट इज सेम एज EF. अच्छा, व्हाट इज द डायरेक्शन? डायरेक्शन इज गोइंग टू बी अलोंग B का. Direction is going to be along B curve. Going to be along B curve. Okay. So now, for that matter, when you have these two vectors like this, vector A and vector B, है ना, तो जब भी आपके पास क्या होगा, वेक्टर B A वेक्टर होगा, just remember this thing. This is vector A. If you were to drop the perpendicular, suppose you drop the perpendicular like this, तो आपके पास जो ये बी वेक्टर है, इट इज गोइंग टू बी ये, इफ दिस इज थीटा, है ना, सो दिस इज प्रोजेक्शन ऑफ वेक्टर ए, है ना. अगर मैं इसको ऐसे डाल दूं और इवन व्हाट यू कैन सी, व्हाट यू कैन फाइंड, आई कैन आल्सो टेक इट लाइक दिस. तो इसका जो प्लेन इसके ऊपर गिरेगा, इसका प्लेन वेक्टर, इसका प्लेन इसके ऊपर जो पड़ेगा, दिस इज गोइंग टू बी एक्चुअली ए cos थीटा. This is A cos theta. This is A cos theta. And this is by definition, it is projection of vector A onto vector B. All right. Now, what you can write? A dot B can be rewritten as AB cos theta. And what you can write? You can write A cos theta into B. So what is this? Projection of, what is A dot B? Projection of vector A onto B, है ना, and V vector. Or in the same manner, what you can write down, similarly, what you can do? Similarly, what you can do? You can write down A dot B equals to A B cos theta. What is this? This is A into B cos theta. What is B cos theta? Projection of B onto A vector. Okay. So what is this? Projection of B onto A vector. That's it. This is the idea. Okay. So that is how we calculate projections. It is going to be very, very important. Sometimes they ask a question, find the projection of this vector onto that vector. But what is the best idea? आपको क्या करना है बेसिकली, मैं आपको बता देता हूँ. जो वेक्टर बी है, उसका यूनिट वेक्टर निकाल के डॉट प्रोडक्ट निकाल दो, है ना. फॉर एग्जांपल, इफ आई वर टू कैलकुलेट projection of A onto B, what is the best strategy? A dot B cap. A dot B cap is going to give you A cos theta. Similarly, B का अगर A पर projection find out करना है, what you are going to do? B dot A cap vector. Okay, so by definition it is okay. So the technique to solve this kind of problem, which you need to understand the mathematics, technique. How do you get A cos theta? the best way to get a cos theta is a dot b cap. How do you get b cos theta? B cos theta is projection of b onto a vector, this is the idea. And when ijk is given, I cap, j cap, k cap is given, how do you do that? You just find out the dot product. Okay, this is the best way to solve such kind of problems. Let's look at the next variety of the problem. How to prove a dot b plus c equal to a dot b a plus c, distributive property you got to prove it. Okay, बताओ कैसे प्रूव करेंगे? Can we do that with the help of projections? Projecting vector a onto b, b onto a. How do you do that? You can try it on. Okay. अगर मैं इसको प्रोजेक्शन की हेल्प से करूं तो लेट्स से दिस वेक्टर इज सम वेक्टर, आई हैव टू वेक्टर्स, लाइक आई हैव दिस वेक्टर ए, है ना, और उसके अलावा मेरे पास दो वेक्टर और हैं. सपोज करो दिस इज बी वेक्टर, दिस इज सी वेक्टर, एंड लेट्स से दिस इज ओके. Okay, all right. So this is vector A, this is vector B, this is vector C, this is vector B plus C. Okay, and if you were to find out it, the answer देखना. So the angle between these two vectors. Okay, so this is vector. Okay, this is vector two vectors. तो मैं इसको खींच के यहाँ ला सकता हूँ. Okay, what I can do, I can rotate this whole system a bit. मजा नहीं आया. What I can do, I can rotate this whole system like this. Okay. Now, suppose करो इस टाइप का system. Okay. Now, what you are going to have, okay, what you are going to have, suppose करो ये वेक्टर लिया है मैंने ऐसा, है ना. तो अब आप इसको कैसे कर सकते हो? What you can do, this is vector b plus c, this is vector a, and if you were to calculate a dot b plus c, a dot b plus c, what you are going to get? A vector b plus c vector into cos theta if the angle is cos theta, है ना. तो अगर आप इसको देखोगे तो जो इसका प्रोजेक्शन है, how do you get the projection? If you were to calculate the projection onto this vector, है ना, तो आप देखेंगे a vector is by definition a into a cap. What is a cap vector? A cap vector is by definition a divided by a. Okay, so b plus c vector dot a cap vector is going to be is going to be same as a b plus c vector cosine theta, है ना. ठीक है. ओके, तो b प्लस c का अगर मैं प्रोजेक्शन देखूं तो इट इज गोइंग टू बी, इट इज गोइंग टू बी इट इज गोइंग टू बी b प्लस c का अगर मैं प्रोजेक्शन देखूं तो a कैप डिवाइडेड बाय a वेक्टर. ओके, a कैप डिवाइडेड बाय a वेक्टर. ऑलराइट, तो if I multiply it throughout this a, so what do I get? If I multiply, okay, so what I am going to get? B plus c dot a divided by a vector. Okay, now if I multiply throughout with the a vector, है ना, तो मेरे पास क्या मिल जाएगा? मेरे पास आ जाएगा a, है ना, अगर आप देखोगे a डॉट b प्लस सी, है ना, a से मल्टीप्लाई कर दिया मैंने, तो a से मल्टीप्लाई करते ही मेरे पास क्या आ जाएगा? देखो b प्लस सी a कैप. एक मिनट, एक मिनट. दिस इज बेसिकली इट इज सेम एज b प्लस सी ए का, ओके ओके, बी प्लस सी कॉस थीटा ना। तो अगर आप ऐसे देखोगे, प्रोजेक्शन ऑफ, लेट मी यूज लाइक दिस, प्रोजेक्शन ऑफ बी प्लस सी onto a vector is this part, this one only, this part. This projection is nothing but b plus c into cos theta. So it is same as b plus c dot a cap, b plus c dot a cap, okay, and which is going to be b dot a cap plus c dot a cap. It is same as b dot a cap plus c dot a cap, है ना? ठीक है, तो यही तो होगा। अगर मैं इसको क्या करूं, ए से मल्टीप्लाई कर दूं, इफ आई वर टू मल्टीप्लाई विथ ए, तो बी प्लस सी, ओके, बी प्लस सी ए से मल्टीप्लाई करते क्या हो जाएगा, बी प्लस सी वेक्टर डॉट प्रोडक्ट with a is going to be same as b dot a into a cap, है ना, b dot a into a cap, ओके, b प्लस सी डॉट ए कैप था ना, तो ये क्या हो जाएगा, a वेक्टर हो जाएगा। सिमिलरली दिस इज गोइंग टू बी c प्लस a vector a cap, but what is this, this is a vector, this is a vector, obviously this has become a vector, so b plus c dot a become b dot a plus c dot a, something like that. This is how you can do that, okay. और कम्यूटेटिव लॉ से क्या हो जाएगा, अगर मैं इसमें कम्यूटेटिव लॉ लगा दूं, कम्यूटेटिव लॉ इज गोइंग टू गिव मी a dot b plus c is same at a dot b plus a dot c, okay, this is how you can prove it, okay. So projection of b plus c onto a is same as projection of b onto a separately, projection of b onto c onto a separately, okay, and with the help of this, with c onto a, c onto a vector, तो अगर इनके प्रोजेक्शन क्या है, सेम है, तो दिस इज हाउ यू कैन डू दैट, ओके, ऑलराइट, तो आई थिंक यू कैन डू इट, okay. Now what we can do, we can solve this question as well with the help of this. So suppose karo you have a plus b dot c plus d, you have to prove this. So from the above problem, what we can do, पहले a को और फिर हम क्या करेंगे, b को इसके साथ मल्टीप्लाई करेंगे, तो a is going to be a dot c plus d, you know, a dot c plus d, प्लस अगर हम बात करेंगे b dot c plus d, you know, फ्रॉम द प्रीवियस प्रॉब्लम, जो हमने अभी ये वाली प्रॉब्लम सॉल्व की थी, फ्रॉम द लास्ट प्रॉब्लम वी कैन डू इट a dot c plus a dot d vector, this is going to be b dot c plus b dot d vector, okay, that is how it is going to be, all right, okay. So this is how it is easily proved, okay. Now quickly we can go for other questions like this. What is I dot I? It is going to be 1. How we do that? 1 into 1 cos 0 equal to 1. So remember, I dot I equals to 1, j dot j equal to 1, k dot k equals to 1. Similarly, I dot j equal to 0, j dot k equal to 0, k dot I equal to 0. What is I dot k? It is going to be magnitude of this vector, okay, magnitude of k vector cos 90, it is going to be 0. What is k dot j? Again, magnitude of k vector, magnitude of j vector cos 90, it is going to be again 0. What is j dot 2i? J dot I equal to 0, j dot j equal to 1, it is going to be minus 3, remaining terms are 0. What is this? 2i dot, now it is good, 2i dot 3i plus k minus j dot ti dot plus k cap. Okay, so you have to use the previously proven formula. 2 3 just 6, I dot k equal to 0, j dot it is 0, so it is going to be only 6. I think you can do that, है ना? तो इसका आंसर क्या आ जाएगा? 6 आ जाएगा. Now it is simple. Okay. Similarly, now what we can prove, because remaining terms, they go away. What is a vector? What you have to prove this one. How do you do that? When u1 a1 equal to b1, because I dot I, remaining terms are 0. Why? Because I dot j equal to 0, j dot k equal to 0. Okay. Similarly, when this a2 goes with only b2, so A2 goes with B2 because J dot J equal to 1 and remaining terms are 0. With the same logic, when this A2 goes with J dot I equal to 0. Okay. Similarly, J dot K equal to 0. And the next term, it goes with A3 goes with B3. है ना? A3, B3, K dot K and remaining terms are 0. With the same logic, you have k dot I equal to 0, k dot j equal to 0. ठीक है? K dot I, k dot j equal to 0, only k dot k equal to 1. So if you have all of this machinery with you, what you can find out finally, A1, B1, A2, B2 plus A3, B3. Again, this is how you should prove it. Because remaining term is going to get eliminated. How do you do that? Again, what is a vector dot with a vector? Magnitude of vector A, magnitude of vector A cos 0. So you are going to get a square. A square equal to a dot A, and from here what do you get? You get a equal to under root a dot a vector. Similarly, from the same logic which we have developed above, it is going to be a1 square plus a2 square plus a3 square, and from there what you can find out, this a vector is going to be a1 square plus a2 square plus a3 square. Okay, this is how it is. So you can solve any question for that matter. Now this question, what is the angle between these two vectors? I know a dot b is going to be, if you were to prove it, 2 6 12, 2 3 minus 6 minus 1 plus 2 2 1 minus 2, है ना? तो कितना आ गया? 4 आ गया. What is a vector? What is the magnitude of a vector? Simply 2 square plus 2 square plus minus 1 square under root 9. It means simply 3. What is the magnitude of b vector? It is going to be similarly 6 squared minus 3 squared प्लस 2 स्क्वायर. तो आपके पास आ गया 6 जगह 36, 9 45, 4 49, 49 अंडर रूट 49 इज सेम एज 7. सो इट इज द एंगल. तो एंगल cos थीटा इज बेसिकली a dot b divided by magnitude of vector a divided by magnitude of vector b. ओके, तो आपका a dot b कितना आया था? a dot b आया था 4 divided by 3 into 7. So 4 divided by 21. Okay, as simple as it is. So each of these questions you should practice. You should get good command over all those things. You get 4 over 21. So, okay, 4 over 21. So cos theta, यानी कि theta equal to cos inverse 4 over 21. If a dot b equal to 0, a and b are not 0, so that a is perpendicular to b. Again, this is easy to prove cos theta. Okay, so आप इसको what you can do, basically you can find out cos theta की वैल्यू, है ना? तो अगर आप देखेंगे a डॉट b इक्वल टू अगर 0 है, तो इसका मतलब a b cos theta equal to 0. Obviously a is not 0, b is not 0, both are not null vectors, so cos theta has to be equal to 0. इसका मतलब theta is going to be pi by 2. Okay, theta is going to be pi by 2. All right. Next one, a dot b equal to 0 if a and b are not 0, so that a is perpendicular to b. Okay, I have proved it. The same question, I think, I have repeated. Determine the value of a, b are perpendicular. Okay, so a dot b has to be equal to 0. So if you multiply 2 4 ja 8, simply आपको same से multiply करना है alpha into, so it is 2 alpha, alpha into 2 minus 2. Okay, and it is minus 2 equal to 0. You have 2 alpha equal to 6, alpha equal to 3. For alpha की value अगर 3 आती हो तो these two vectors are going to be perpendicular vectors. All right. So we are going to wind up this session today in here only, है ना? So because of something came up in the meanwhile, I'm going to start, another session with again 50 minutes long video. Thank you so very much. See you guys until next time. Till then, goodbye. Thank you.